In question 26, it says a truck covers 40 meters in 8.5 seconds while smoothly slowing down to its final speed of 2.8 meters per second. A. Find its original speed. B. Find its acceleration. Well, this is an example of what is called a constant acceleration problem. Constant acceleration referring to increasing or decreasing our velocity at a constant rate. Now, when you identify this concept, you're going to be using one of four equations. Here they are. The first equation is V equals V naught plus AT. When you see this symbol here, this symbol is pronounced V naught. And it stands for the initial velocity. So instead of writing VI, we're going to write V sub 0, pronounced V naught. A final V, written in the problem, is the final velocity, without having to write V final. A stands for constant acceleration, and T is time. So if you have these variables, V, V naught, acceleration, and time, you would choose this first equation here. In the second equation, if you have the variables x, x naught, v naught, a, and t, you would use this equation here, which is x equals x naught plus v naught t plus 1/2 times a times t squared. If you have these variables listed in the problem, v, v naught, a, x, and x naught, where x is the final position or final location of the object, and x naught is the initial position or initial location of the object. Please remember this. Assume x naught, the initial position, to be 0 unless the problem states otherwise. It kind of makes sense that we simply start from a location of 0. That will simplify the equation quite well in most cases. If those variables are present in the problem, we will use this formula here. V squared equals V naught squared plus 2a times the quantity x minus x naught. And lastly, if we have these variables here, a change in position, x and x naught, a change in velocity, v and v naught, and time, then we can use the equation delta x, which you might remember is x minus x naught, and that's equal to v plus v naught over 2 times t. Something to consider when you're using these formulas. These are the don't have variables. I will use the first equation if I don't have x or x naught. So if I don't have position, then the first equation is a good one to use. If I don't have v final, the second equation is a good one to use. If I don't have time, the third equation is a good one to use. And if I don't have acceleration, the constant acceleration A, the fourth one is a good one to use. That might be a helpful way of trying to figure out which equation to use. Is not necessarily which variables you have, but more importantly, which ones you don't have in the problem. You'll see this as you continue to practice many of these constant acceleration problems. Okay, let's reread question 26 again. A truck covers 40 meters in 8.5 seconds while smoothly slowing down to its final speed, 2.8 meters per second. Find its original speed, find its acceleration. Well, here we go. It's a constant acceleration problem, and part B, find its acceleration. We don't know its acceleration. That would tell me I am leaning more towards that equation there. But before we start jumping into an equation, we want to have a method for doing constant acceleration problems. First step, identify the problem as its concept, constant acceleration. Second thing is Make an immediate list of variables. There are 6 possible variables in any constant acceleration problem. List them the same way all the time. X, x naught, v, v naught, a, and t. Now, when you do a problem, you will know 3 of these 6 variables. Anytime, you will always know 3 of these 6. You will not know 2 of the 6, one of which you don't even care about, one of which is the variable you don't have, which eliminates that particular equation from being used. Let's go back and reread it a third time, this time for information. A truck covers 40 meters in 8.5 seconds while smoothly slowing down to a final speed of 2.8 meters per second. Well, it doesn't tell us the initial position, so I'm assuming the initial position to be 0. It tells you the truck covers 40 meters, so that would be a final position of 40. It tells you the final speed is 2.8 meters per second. It does not tell you the initial speed. In fact, in part A, it wants you to find the original speed. So V naught is our question mark for part A. And then the acceleration is our question mark for part B. The time we are given is 8.5 seconds. Now, again, looking at this right here, I list my concept, constant acceleration. I list my 6 variables. Anything identified in the problem, again, what did I mention before? You will always know 3 to 4 of those variables. I know these 4 variables. I don't know these 2. Both of them happen to be my unknowns in the problem. Since I don't know acceleration, I'm going to lean towards this equation here. Delta x equals v plus v naught over 2 times t. Now, the next step after identifying the equation is to solve it for its variable and isolate it for the variable. Do not get in the habit of plugging in numbers right away. That will mess you up when it comes to AP exam preparation when the problems do not have any numbers and are variable only. Please try this practice of solving the equation first. We need to solve and isolate for V naught, which basically means we need to get rid of t, 2, and v. Since there's 3 things to get rid of, it's a pretty good assumption that this might take 3 steps to solve. Let's begin. First thing I'm going to do is I'm going to recopy down the equation. This time I'm going to begin by multiplying everything by 2. That gets rid of this. And simultaneously dividing by t. That gets rid of this. Now, if I rewrite this, I get 2 times delta x over t equals v plus v naught. Now again, I need to solve for v naught. So I need to get rid of the v. Since the v is a positive quantity, I can subtract the v to both sides. Rewriting this, v naught is equal to 2 delta x over t minus v. Now that v naught is isolated, substitute the numbers into the equation that is isolated for v naught. 2 times the delta x of 40 meters over the time of 8.5 seconds minus the final speed of 2.8 meters per second. Plug that in our calculator. 2 times 40 is 80. 80 over 8.5 is 9.4 minus 2.8 gives us approximately an initial speed of about 6.6 meters per second. Part B wants to know the acceleration in the problem. So this was all part A. Now, acceleration, you have three possibilities. I see three equations that have acceleration in them. Now, sometimes we just have to work smarter, not harder. I'm thinking we use the first equation since it has the fewest variables that we already know and is a much easier equation to solve. V is equal to V naught plus A times T. To solve for A, I need to subtract V naught both sides. And when I rewrite this, I get V minus V naught equals A times T. Divide both sides by T, and now A is by itself, and that would be V, which is 2.8 meters per second, minus V naught, which is 6.6 meters per second, over the time of 8.5 seconds. 2.8 minus 6.6 divided by 8.5 gives us roughly negative 0.45 meters per second squared. What this basically means, this means right here, this negative means two things. One, the object is slowing down. Two, it's moving forward. Those two things are symbolized by that negative acceleration.